Today's topic is going to be linear regression and correlation. This is some of a couple sections from chapter 3. I'm just going to kind of go my own order. And this is some data from my A2 class. If this was your class, you've seen it in B2, you did something similar, but it's not important which one it came from. What I need you to do is to pause here and to enter this data into your calculator. So you can go ahead and pause and do that. Once you have entered this data in your calculator, you should have something like this, stat edit, and there are our x's, our heights in list 1, and our number of steps in list 2. So we're going to do basically everything we do today in the calculator, so we're going to need to have a set of data to work with. Keep this list in your calculator, these two lists, so that we can use them for further things as well. Okay, so let's get back to today's topic, linear regression and correlation. Linear regression is a process where we are going to put the best case scenario line through the dots. We're going to draw a straight line. These are all straight lines. We'll talk about other kinds of regression later, but we want the line through our dots that is as close to all the dots as possible. Specifically, we're going to use what's called the least squares regression line. What least squares means is if you take each dot's vertical distance from the line and you square that number and add those together, then this is the line that minimizes that total. Basically, all you need to know is that it's the closest we can get to all of the dots combined. It's the best fitting line that goes through those dots. So let's talk about how to find that first. So once your data has been entered into your list, then we're going to go back to stat where we start. We're going to go over to calc. And what we are trying to do is linear regression. Now, I see that option 4 is linreg. That's linear regression. That's AX plus B. There's not really any difference between that and 8. And honestly, I'm not sure why we have another one. But I do know that option 8 is the one we want to use, linreg A plus BX. So I'm going to hit linreg A plus BX, option A. It's defaulted to list numbers 1 and 2. So you can go ahead and hit enter. I'll show you a few other options in just a minute. And what this gives us is the equation of a line. The equation of this line is y equals 287.653 repeating minus 2.365 times x. $287.653 repeating. Plus, actually that's going to be minus because our slope is negative, because the taller we were, the fewer steps it took, negative 2.365x. So this is a line just like y equals mx plus b in algebra 1. This is the y-intercept of that line. This is the slope of that line. One thing that's going to be important that you're able to do is to interpret those values in context. We're going to use context over and over in this class. You need to be able to apply this to what we're talking about. And don't just say the line goes down 2.365 for every step to the right, but put that into context. Our y-intercept context isn't going to make a whole lot of sense in the real world. What that's saying is if a person were 0 inches tall, that it would take them 287.653 steps to get around. A lot of times with the y-intercept that won't work. If x is 0 is not a normal value, then the y-intercept won't make sense. The slope, however, negative 2.365 means for each additional inch of height, it should take about 2.365 fewer steps to get around the hall. So make sure that you are able to interpret those in context, because you will get asked to do that lots of times. Let's go back to our calculator. Here's the regression line. If you go to stat plot, You turn plot 1 on and you select the scatter plot option. And remember, zoom 9 is how we get to our dots. Here's the scatter plot that we drew in class. All right, so not a whole lot of information here. If you hit trace, you can go through it a point at a time and get the data points. But other than that, you know, it's just kind of neat that your calculator will do this. What would be really nice is if we could put that line through that equation, or through those dots. So one option would be to go here to y equals and to enter the equation that we just found and add it. But here's a better option. We entered our data. We go to stat, calc, option 8, not option 4. If you tell this before you hit enter where to put the equation, then it'll put it in there automatically. So we want to say put this into y1. There are actually 3 commands. If your lists are ever not 1 and 2, you want to hit second, the number 1 for list 1, comma, second 2. And this is telling your calculator use the x's in list 1 and the y's in list 2, just in case we ever are using other lists. Put another comma. Now go to vars, which is 3 buttons above the 9. Go over to yvars, select function, select y1, and now what you're telling your calculator is calculate the regression line using x's in 1, y's in 2, and put the resulting equation into y1. And there we go. You might, by the way, have r and r squared below your a and b. For right now, well, I'll tell you about that in just a minute. For right now, if you have that and I don't, it's no big deal. So if you go to y equals now, you can see that the equation that we wrote down earlier has been put into y1 for us. And if you go back to the graph, you'll notice that the line has been drawn through the dots for you. Okay, so now that we know how to find that line and put it through the graph, what's the purpose of this line? The reason we calculate a regression line is to not only interpret the intercept and the slope, but to use it to make predictions. So what if somebody was absent from class and they come in and they are, 5'2". So what if x equals 62 inches? Then what's y equal? Well, we just plug that value in for x and see. We can predict how many steps it would take them. And I know, and this isn't a real something you really want to know about, but just imagine it where we could use this line to try to get a close value what y will be given an x. And we can, by the way, if you hit second calc from this screen, calculate a value, and then plug in any x you want, let's say 66, it'll give you what the line predicts. This line predicts that a 66-inch tall person will take 131.563 steps to get around. Okay, so you can plug in x values in your calculator like that. If you have to plug in a y value, it's not as easy. You can't just go somewhere and tell what y is. But let's say you wanted to know how tall someone would be if it was going to take them 140 steps. Well, you can go to y equals, graph an additional line of 140, go back to your graph, and there's the line for 140. To find the intersection of those, go to second calc, intersect, option 5, and pretty much you just hit enter 3 times. For the guess, you can scroll over to get close to the intersection, and we see that if it's going to take 140 steps, that person's about 62.4 inches tall. It's easy to input an x and get a y. It's a little bit more time consuming to input a y and get an x, but that's okay. That's how you would do that if you needed to. So linear regression, that's pretty much what you need to know about it. You need to know how to get the perfect line, the so-called perfect line, the best fit line, and you need to know how to use it to make predictions. We'll talk in class a little bit about the equations that give you those. They're on your pinkies and your goldies. We're going to 90% of the time use our calculator, but sometimes you'll need to know the actual equations for a certain AP question, and we'll do that when we need to. So let's talk about correlation. If your calculator, when you do stat calc 8, if your calculator is giving you a, b, r, and r squared, you can ignore what I'm getting ready to say. If it's just giving you a and b, then you need to do this. Go to your catalog, second 0. You need to scroll down to the d's. Your alpha is already turned on, so if you just hit D, it should scroll you down. We need to go to where it says Diagnostics On. Hit that and hit that again. I don't know why, but sometimes those are turned off, but we need to turn them back on. Once you turn it on, it should stay that way. Now if I go Stat Calc 8, I get two other values, R squared and R. The one I want to talk about right now is R. That's correlation. Make sure you get this definition written down. Correlation is a value that is the letter R. It's always between -1 and 1. That indicates the strength of the linear, because we're doing linear regression, linear relationship in the data. So when we first started talking about scatter plots, we did form, direction, and strength, and we kind of had to say, well, it's medium strong, it's kind of strong, it's weak. We didn't really have any values to put to how tightly packed the dots were along their line. Correlation is going to give us a numerical value for that. And just a quick sketch here, for example, it's between -1 and 1, and the -1 isn't the weakest. -1 and 1 are both strong, but they're in different directions. So these are not going to be highly accurate, but just quick example. The least correlation is 0, and that's if your dots are completely spread out everywhere. There's no line to them. Perfect correlation would be -1. If your dots are going down and they're in a straight line, that's a correlation of -1. If your dots are going up in a straight line, then it's +1. And then we have everything in between that. You know, R equals, I'll just use -0.8 for an example. It might look something like this. R equals 0.5. +0.5 will be going up, and it will be slightly less linear. There's some good pictures in your book that you can look at. And it's hard to estimate like what a 0.8 or a 0.5 would look like. But what you need to know is -1 and 1 are perfect correlation in opposite directions. 0 is a complete cloud of no pattern, and everything in between is some strength of linear relationship. All right, so in our calculator, here's an example. This is -0.78, and that's what the picture looks like, so you can kind of get an idea. Don't try to look at dots and determine what the correlation will be, because that can be misleading. But this is close to -0.8, so it's a fairly high number in the range of 0 to 1, almost a 0.8. And these dots still aren't very strongly gathered around that line. So just one example here. So what correlation will do? Oh, and by the way, the other number, the R squared, we'll get to later. It's called the coefficient of determination. We'll talk about that one later. So for this particular video, what you need to be able to do is input your data, calculate the equation of your line, use that line to plug in x's and or y's, which all can be done by hand, by the way. You don't have to do that in your calculator. You need to be able to find your correlation and interpret it. So our correlation being -0.78 is it's a fairly strong, and I'll give you breakdowns of what makes it strong and what makes it weak in class. But it's a negative relationship that's pretty close to -1. We'll get into that more later. All right, so that's linear regression. Young out.